Where we're going to start now is to show you how to use a free web-based calculating graphing software that we think is very useful and which can be applied very nicely to the topics in algebra that we're going to use. So you're going to find this at www.Desmos.com. And depending on your browser, it might vary a little, but you will see this launch calculator, which you're going to have to click on to launch it. And that launches the calculating and graphing software. What appears underneath here might be different, but this is where you want to start. You want to launch the calculator. Once you click here and launch, what you're going to see is this screen right here, or something closely equivalent to that. So you'll have some area in here for graphing, which we're not going to use right away. Here's where we enter our formulas, our equations. We can enter table of values. We're not going to do it in this particular lesson. And we can answer, we could input text. So you have these three. If you click on this arrow here, you can see that this is for an equation, this is for a table of values, or this is for text. So you have the option of entering these here. Here's the keyboard that you see. So the keyboard is right over here. And you can see of the less than, greater than, square root, power. You also have different kinds of trigonometric functions, which we won't use. You can collapse the keyboard here by clicking on this button. Now, a very useful button up here is the question mark here, which leads to help. And that's the first place you should really start. Before you do anything, you should click on the question mark, which is the help. And here's what you're going to see. You're going to see the basic same window, except it will indicate the resources that you have to learn. So you can download the user manual PDF form, 11 pages. That's very useful. You have how-to videos right underneath here, so you can just click on these and look at them. For example, today we're going to look at sliders. In the future, we're going to look at restrictions, and we're also going to use things like points of interest. So you can go ahead and look at these. You may not understand everything, but every time you look at it, you sort of pick up an additional piece of information. It's good to go back and take a look at that instructional part of Desmos. So now here what we're going to do is we're going to use Desmos to do some simple calculations from topic 1, just to reinforce what we've learned in topic 1. You don't have to do this. It's just optional. Just makes things a little more interesting and maybe a different perspective. So here we're going to set a equal to -3. We put that into box 1, and we're going to set b equal to 5. And underneath you will see automatically these sliders appear. And these allow for the variation of the values of a and b, so we're not fixed to this. If you move this slider right here, put your mouse on it, press down, and move it along the blue bar here, you can change the values. Similarly, you could do for here. Now, if we look here, we're asking the calculation a minus b. So this would be -3 minus 5. So minus 5 is +5, and -3 + 5 would give us 2. I get exactly the same. All I'm doing difference between here is putting a number 1 before the bracket. And 1 on a multiplication doesn't change anything, so I get the same answer. And a minus b is the same as a plus b. So you can see the answers which appear here on the bottom. The solution to this appears on the bottom right are all the same. So these these three expressions in box 3, box 4, and box 5 are equivalent expressions. So these all relate to addition and subtraction. But if we look at multiplication, we set up a different set. We put a equal to minus 3, b equal to 5, and we change here. We put a product b, a dot b, which is the same as this, or put a bracket around the a and put a bracket around the b. In all these expressions, box 3, box 4, box 5, all lead to the same answer, minus 15, because minus 3 times 5 is minus 15. So whether we write it like this, we write it like this, or we write it like that, we get the same answer. By the way, this little dot in the middle you can get off the keyboard, and these you can just either enter through your keyboard or manually using the brackets on your own keyboard. So you can do it through the keyboard. When I'm talking about, there's two different keyboards here. So you have your keyboard, which is separate from this one, or you can click on these here and you've got the keyboard here, which is built into the Desmos software on the web. So now, by the way, here is a divided by b, so minus 3 divided by 5, the answer is here, minus 0.6. Here are operations involving 0, so we could have 0 on the denominator, on the numerator, divided by a number, which would give us 0. So 0 divided by minus 3 gives us 0, but the reverse of that, where we put 0, here in this particular case, we got minus 3 divided by 0. If 0 is on the denominator, it's undefined, and in Desmos they write minus infinity because the a is minus 3. So minus 3 divided by 0, they write it as, give it as minus infinity, which is the same as what we call undefined. It's not defined. Now here's a very useful little feature of Desmos, and we're going to use it to show the number line that we discussed in topic 1. First of all, the notation x comma y's used in the boxes. So over here you'll see this notation. X represents the value along the horizontal axis. This is the horizontal axis. And y represents the value along the vertical axis. So that's this axis here. Along this number line, y equals 0. So we only have the x values along here. By the way, this is my notation here, right here. This is not from Desmos. This is my notation, this is my notation, etc. All these are my adding on to the information that you get from Desmos. But here what we're going to do is we're going to use this notation x comma y, but because along this, the real number line in topic 1, y has no value, we're going to set y to 0 in each one of these cases. So right over here, y will always be 0, and what we're looking at is the x value. This is the x value, this is the x value, and this is the x value here. We set a equal to minus 3 and b equal to 5. So, for example, if we take a minus b, what would that be? A minus b would be minus 8. So that's the answer to box 3, this calculation here. This is minus 8 comma 0 when a is minus 3 and b is 5. And you can see this is color-coded with this. It's black. We go to box number 4. We've got minus 3 minus 5, which is plus 5, and that will give us 2. So that's this value right over here. So the answer for what's in box 4 is right here, 2 comma 0. then we go to the last one, minus a, which is minus 3, which is 3 plus 5 is 8. So that's this value over here. And this is color-coded to these. So each one of these dots has their own color code along here, so it becomes useful. Oh, by the way, the way that you see this color code in clear is to click on the Tools button on the top and click on Projector Mode, and that makes these dots right here larger. So where is this? Let me show you this Tools button where it is, right here. You have to click on that, and then you click on Projector Mode, and these dots become much larger than they normally would. So this is a way to sort of understand how this, how you can set up the real number line using a specific function here. You must use the square brackets, and this is your x value and this is your y value. We've all set this to 0. And don't worry if you don't really follow this as far as respect to x comma y. We're going to discuss this later on under rectangular coordinates. I think it's topic 4, so you can always come back to this later on. Now, properties of real numbers, which was also part of topic 1, we can show here we set a equal to 6, b equal to -4, and c equal to 2. Here we've got a, b plus c. We're going to use the distributive rule. A times b gives you ab, and a times c gives you ac, and because you have a plus sign here, it becomes a plus sign here. So this is equivalent to that. So we're using the distributive rule, and notice that we get the same value. Even if you change the value of the sliders, it doesn't matter. You'll still should get the same value here because this is equivalent to that. You can change the value of the sliders just to make sure. See, what we're doing is we're showing a static diagram from Desmos. We're not showing Desmos live. So anyway, here, this is just an example of the distributive rule. Now what's happened here in 6 is I deliberately made an error on purpose, and I said that a times b gives you ab. That's okay, but a times c gives you bc. Well, that's an error. It should be ac. So I deliberately made an error here, and you can see that the value is wrong. So what's in box 4 is not equivalent to box 6. I made an error on purpose, and it shows how you can, check things out, how you can use Desmos to verify. Now, so we've used the distributive rule here. Now we set the same thing up here, a equal to 6, b equal to -4, c equal to 2. And what we do is we've got a plus b plus c. So we group b and c together and then add them to a. Here we've grouped a and b together before we add it to c, but the answer still comes out the same. So if we just go one step further, that's addition rules. If we do the same thing for multiplication, you can see here we've multiplied bc together, then multiplied it by a, or a multiplied by the product of BC. Here we've taken the product of AB and then multiplied by C, but we still get the same answer. So 6 times -4 times 2 gives us -48. It doesn't matter how we multiply this. We could multiply 2 times -4 times 6, 2 times -4 times 6, and we still get -48. So what we've done here is try to give you a bit of introduction to how you can use Desmos. So I think the most important thing is to play around. First of all, download the user manual, see how much you understand and how to videos. Now, at the beginning, you may have trouble following this, but after you've used Desmos a few times, you're going to gradually increase what you know, and the flexibility. You're going to see the flexibility of Desmos. So this completes our introduction into the use of Desmos.